The science of rain, how precipitation forms and falls. Rain, the Earth's most precious natural resource, is often taken for granted. While we all know what it is and how it feels, not many of us know how it forms and falls from the sky. The science behind precipitation is fascinating and complex, involving a range of atmospheric processes and physical phenomena. In this video we will explore the science of rain and how it occurs. From the formation of clouds and the role of temperature and pressure, to the various types of precipitation and the ways in which it impacts our daily life, we will cover everything you need to know about the science of rain. So, grab your umbrella and let's dive into the fascinating world of precipitation. 1. What is precipitation? Precipitation is one of the most important components of the Earth's water cycle. It is the process by which water droplets or ice crystals form in the atmosphere and eventually fall to the ground. Precipitation comes in many forms, including rain, snow, sleet, and hail. It plays a vital role in maintaining the Earth's ecosystem and is responsible for replenishing the planet's freshwater supply. The process of precipitation begins with the evaporation of water from the Earth's surface, such as from oceans, rivers, and lakes. As this water evaporates, it combines with other gases in the atmosphere and forms water vapor. This water vapor then rises into the atmosphere and cools down, causing the water vapor to condense into clouds. As the clouds continue to grow and expand, the water droplets or ice crystals inside them become heavier and eventually fall to the ground. The type of precipitation that falls depends on the temperature and humidity levels in the atmosphere. For example, if the temperature is below freezing, the water vapor will freeze into ice crystals, leading to snow or hail. Precipitation patterns and amounts can vary greatly depending on location and time of year. Some areas, such as tropical rainforests, receive high amounts of rainfall throughout the year, while others, such as deserts, may only receive precipitation sporadically. Understanding the science of precipitation is crucial for predicting weather patterns and managing freshwater resources. 2. The water cycle, how rain forms and falls. At its core, rain is formed through the water cycle, a continuous process of evaporation, condensation, and precipitation. It all starts with the sun heating up the Earth's surface and causing water to evaporate from various sources such as oceans, rivers, lakes, and even plants. As water vapor rises into the atmosphere, it cools down and condenses into tiny water droplets or ice crystals. These small droplets and crystals cluster together to form clouds. As more water vapor continues to rise and condense, the droplets in the clouds grow larger and heavier until they become too heavy to stay afloat. This is when precipitation occurs and the water droplets fall back to the ground in the form of rain, snow, sleet, or hail depending on the atmospheric conditions. Rainfall occurs when the water droplets in a cloud combine and become too heavy to remain suspended in the air. This can happen due to various factors such as cooling temperatures, strong winds, and changes in air pressure. As the droplets fall, they can combine with other droplets and grow larger, ultimately resulting in the rain that we see and experience. The entire water cycle is a remarkable process, and understanding how it works can help us appreciate the science behind rain and the importance of this natural phenomenon for our planet. 3. 3 ways to cool air to its dew point. There are several ways to cool air to its dew point, which is the temperature at which the air becomes saturated with water vapor and condensation begins to form. The 3 most common ways are: 1. Cooling by radiation. This process involves the transfer of energy in the form of electromagnetic waves, such as sunlight or thermal radiation, from one object to another. When the Earth's surface cools at night, it radiates energy to the atmosphere, which can lower the temperature of the air and cause dew to form on surfaces. 2. Cooling by adiabatic expansion. This process occurs when air rises and expands due to a decrease in atmospheric pressure. As the air expands, it cools adiabatically, meaning without the exchange of heat with the surrounding environment. This cooling can cause the air to reach its dew point, leading to the formation of clouds and precipitation. 3. Cooling by evaporative cooling. This process involves the transfer of heat from the air to water vapor as it evaporates. As the water vapor absorbs heat, the surrounding air cools, eventually reaching its dew point and causing condensation to occur. This process is often seen in hot and humid climates, where rapid cooling of the air can lead to thunderstorms and heavy rainfall. Understanding these processes is essential in predicting and understanding precipitation patterns. By understanding how air cools and water vapor condenses, we can better predict rainfall and plan for its effects on our environment. 4. Types of precipitation. Precipitation is the process of water falling from the atmosphere to the surface of the Earth. There are 4 main types of precipitation that occur: rain, snow, sleet, and hail. Each type of precipitation is formed under different atmospheric conditions. Rain is the most common type of precipitation and occurs when water droplets in the atmosphere merge together to form larger droplets that are heavy enough to fall to the ground. The droplets can vary in size and can fall as a light drizzle or a heavy downpour. Snow is formed when water droplets in the atmosphere freeze into ice crystals. These crystals then combine to form snowflakes that fall to the ground. Snowflakes can vary in size and shape depending on the temperature and humidity of the air. Sleet is formed when snow falls from high altitudes and passes through a layer of warm air before reaching the ground. This causes the snowflakes to melt into raindrops. As the raindrops fall through a layer of freezing air, they refreeze into small ice pellets before reaching the ground. Hail is the least common type of precipitation and is formed during severe thunderstorms. Hailstones are formed when strong updrafts in the storm carry raindrops high into the atmosphere where they freeze into ice pellets. The pellets then fall back down to the ground, being carried back up and down by the updrafts, adding layers of ice until they are heavy enough to fall to the ground. Hailstones can vary in size and can be as small as a pea or as large as a grapefruit. 5. Rain. The lifeblood of ecosystems around the world. Rain is the lifeblood of ecosystems around the world. It provides the necessary moisture that supports the growth of plants and sustains animal life. Regions that receive more rainfall tend to have more abundant and diverse plant and animal species. Rain also plays an important role in the water cycle, where water evaporates from the surface of the earth, forms clouds, and then falls back to the ground as precipitation. Rainfall is especially important in arid and semi-arid regions where water is scarce. In these areas, even a small amount of rain can make a big difference by supporting the growth of crops and replenishing groundwater reserves. Rain also helps to reduce the risk of wildfires by keeping vegetation moist and reducing the amount of dry fuel available to burn. However, too much rainfall can also be detrimental. Heavy downpours can cause flooding, landslides, and other natural disasters. In addition, excessive rainfall can wash away topsoil and nutrients, leading to soil erosion and reduced fertility. In conclusion, rain is essential for the health and well-being of ecosystems around the world. It provides the water needed to sustain life and plays a vital role in the water cycle. However, it is important to manage rainfall effectively to prevent both droughts and floods and ensure the long-term sustainability of our natural resources. 6. How much rain falls in different parts of the world. Rainfall varies significantly in different parts of the world. Some regions experience heavy rainfall for months, while others may receive only a few inches of rain per year. Areas near the equator generally receive higher amounts of rainfall due to their warm temperatures, which promote the formation of clouds. On the other hand, regions near the poles receive less rainfall because cold air cannot hold as much moisture as warm air. Additionally, mountainous regions often receive higher rainfall due to the orographic effect, where moist air is forced to rise over mountains, which cools the air and causes precipitation. The amount of rainfall also varies depending on the time of year. Some areas experience a rainy season during which most of the year's precipitation falls, while others have a relatively even distribution of rainfall throughout the year. Understanding the patterns of rainfall in different parts of the world is essential for agriculture, water management, and disaster preparedness. With this knowledge, governments and communities can develop strategies to cope with drought, floods, and other weather-related issues that may arise. 7. The relationship between rainfall and climate change. Climate change has become a major concern in recent years, and its effects on rainfall patterns are a significant area of study. As global temperatures continue to rise, the amount of moisture in the atmosphere increases, which can lead to more frequent and intense rainfall events. This can cause problems in areas prone to flooding and landslides. Conversely, climate change is also leading to more severe droughts in some parts of the world, as increased temperatures cause more rapid evaporation of moisture from the soil and plants. Scientists predict that these changes in rainfall patterns will have significant impacts on ecosystems, agriculture, and human populations around the world. Some areas may experience more frequent and severe storms, while others may experience more prolonged dry spells. It's important to note that changes in rainfall patterns are just one aspect of the complex and interconnected system that is our climate. It's crucial that we continue to study and understand these changes so that we can take action to mitigate their effects on our planet and its inhabitants. 8. Measuring and predicting rainfall. Measuring and predicting rainfall is incredibly important for a variety of reasons, from agriculture to disaster preparedness. One of the most common tools used to measure rainfall is a rain gauge, which is essentially a container that collects precipitation and allows for measurement of the amount of water that has fallen in a given area. Rainfall is also predicted using a variety of methods, including satellite imagery, radar systems, and weather balloons. These tools can provide valuable data on the amount, intensity, and location of precipitation, which is crucial for planning and decision-making in many industries. Weather forecasting models, which use complex mathematical algorithms to analyze and interpret data, are also key to predicting rainfall. These models take into account a variety of factors, including temperature, humidity, wind patterns, and atmospheric pressure, to make predictions about when and where rain will fall. In addition to helping farmers determine when to plant and harvest crops, rainfall data is also used to manage water resources and plan infrastructure, such as dams and reservoirs. By accurately measuring and predicting rainfall, we can better prepare for both the benefits and the risks associated with this essential natural phenomenon. 9. The impact of too much or too little rainfall. Rainfall is an essential component of the Earth's ecosystem. It provides the water required for plants to grow, replenishes rivers and lakes, and maintains the balance of the natural environment. However, too much or too little rainfall can have a significant impact on our world. When there is too much rainfall, it can lead to flooding, landslides, and other natural disasters. Floods can cause destruction to properties, infrastructure, and even human lives. On the other hand, when rainfall is scarce, it can lead to droughts, water scarcity, and crop failure. These problems can lead to food shortages, economic problems, and even deadly conflicts over resources. Climate change has been linked to the increase in extreme weather patterns, including heavy rainfall and droughts. As the global temperature continues to rise, weather patterns are becoming more erratic, leading to more frequent and severe weather events. It is important to understand the science of rain and the impact of rainfall on our environment. By doing so, we can take measures to mitigate the negative effects of too much or too little rainfall. This includes building better infrastructure to prevent flooding, developing more efficient irrigation systems for agriculture during droughts, and implementing sustainable practices to reduce our impact on the environment. 10. Conclusion: the importance of understanding precipitation. In conclusion, understanding precipitation is crucial for various reasons. Firstly, it is essential for predicting weather patterns and forecasting natural calamities such as floods, hurricanes, and droughts. This knowledge can help people in vulnerable areas prepare for these events, reducing the impact on human life and infrastructure. Secondly, precipitation plays a vital role in the water cycle, which is responsible for maintaining the balance of water on our planet. Understanding precipitation and the water cycle is essential for maintaining ecological balance and sustaining life on Earth. Finally, an understanding of precipitation can help individuals and industries make informed decisions about water usage, conservation, and management. By knowing when and how precipitation occurs, we can better plan for its usage, minimizing waste and ensuring water is readily available for our needs. In conclusion, precipitation is a fascinating and essential aspect of our environment. It is crucial to understand how it forms, falls, and interacts with our natural and human-made surroundings. By doing so, we can better prepare for weather events, maintain ecological balance, and make informed decisions about water usage and management. We hope you enjoyed our in-depth exploration of the science of rain. Rain is a natural phenomenon that has fascinated humans for centuries, and understanding how it forms and falls is an important part of appreciating the natural world around us. From the basics of precipitation to the more complex processes that lead to rain, we hope this article has given you a better appreciation for the science of rain. Next time it rains, take a moment to observe the beauty and complexity of this incredible natural phenomenon. Please like the video and subscribe the channel.